Hello YouTube. This is a presentation about the half adder digital circuit, and we're going to go through the derivation and the explanation of what it is. So let's get started. Our motivation is that we have 2 bits and we want to make a circuit that can add the 2 bits and show the sum. So in this case we have bit A and bit B, and they're shown over here on the left of our rough diagram here. A and B are inputs to our device, or this box here. And we have 2 outputs, S, which is the sum, and C out, which is the carry out. I'll explain what that is in a second. Now, what we're trying to do is we're trying to find out what is the logic inside this box that will get us to add up A and B, to add up these 2 digits. Now, the carry out that I mentioned, why do we need that? Well, when we consider the addition of a pair of single digits, for example, 8 plus 5, we know that's 13. Um, we have in the single digits, we have a 3, and then we have a carry out of 1. This is a long way of saying 13, but the tens place gets it added to. It gets a 1 added to the tens place, and that makes 13. Whereas when we look at example 2, 4 plus 3, the sum is 7, and the carry out is 0. There's nothing going to the tens place. Whereas in example 1, 8 plus 5, we spilled into the tens place. We have that extra 1 here. Bit addition works similarly. So in this first example, we have 1 plus 0. The sum is 1. The carryout is 0. Nothing is moving to the next digit's place. So the result is 1. 1 plus 0 is 1. Example 2, when we add 1 plus 1, now we have something moving to the next place, the next digit's place. So we have a sum of 0, and the carryout is 1, leading us to the result of 1, 0. When we derive the logic, we first consider all the possible inputs. So this shaded area in pink here shows all the possible digits from in that were going to A and B, 0, 0, 0, 1, 1, 0, and so forth. This section on the right that's shaded is all the outputs that we want to happen. We want these to happen for all these inputs. Now you might ask yourself, like, how do we know that these are the outputs? That these are the outputs? And the reason is we look at the combinations of A and B. When A is off and B is off, we want a sum of 0. When A is off and B is on, that's like adding 0 plus 1, we want a sum of 1. When A is on and B is off, that's like adding 1 plus 0, we want a sum of 1. When A is on and B is on, that's like adding 1 plus 1. So in that case, we want a sum of 0, but a carryout of 1. We want that 1 to move to the next digit's place. So let's try to achieve this logic. The way we do that is looking at where the sum is 1. So in this case, in the red box here, the sum is 1 only in 2 cases. And the 2 cases are when either A or B is on, but only one of them is on. So either A is on or B is on, but not both of them. And the way we achieve that is by using an XOR gate. So this sum truth table, this section of the truth table in red, is achieved by getting a gate that says A XOR B, or like the logic A XOR B, and that'll achieve this, the 2 green spots here. The carryout is achieved by looking at where it is 1. So in this green section here, the carryout is 1. When is it 1? When A and B are both 1 and 0 everywhere else. And we can achieve that through an AND gate. So A and B gives us this behavior. A and B, it'll only be on when both A and B are on. And that's how we get that. So here we can see the circuit. We have A and B are inputs feeding into a XOR gate, and we have A and B both feeding into an AND gate. And from the XOR gate, we have the sum, and from the AND gate, we have the C out. So let me pause for a second and open up my other browser. So here we can see it in action. We can see this in action. So we have the same circuit, an XOR gate and an AND gate here, and we have the sum out and sum and the C out here. These are all bits. These are 2 switches for A and B. and 2 output bits. So let's turn A on and see what happens. I turn A on, that's like adding 1 plus 0, A plus B, 1 plus 0, and we get a sum of 1. Now let's try turning B on. This is like adding 0 plus 1. We get a sum of 1. Now let's try turning A and B on. So what we expect is the sum should be 0 here, and the carryout should be 1. And that's the behavior we get. So yeah, that was just a short presentation. Let me know if you have any questions, and I will clarify what I can. Thank you very much. Bye-bye.